The relation between the terminal voltage V, the electromotive force epsilon, the current I, and the internal resistance R of the battery was also obtained. V is equal to epsilon minus I into R. If a table voltmeter is connected across the two terminals of the battery, it will measure the potential difference between A and B. That means only the terminal voltage of the battery. If the internal resistance of the battery is 0, or while measuring the voltage, the current passing through the battery is 0, then according to equation, V is equal to epsilon minus I into R. V is equal to epsilon, and the terminal voltage of the battery becomes equal to its electromotive force. But the internal resistance of the battery is never equal to 0. As a result, electromotive force of the battery can only be obtained if no current passes through the battery. The condition of no current passing through the battery is known as an open circuit condition. Simple voltmeter has resistance of about 5000 to 6000 ohms. Hence, upon connecting it to a battery, some current loss does flow. Hence, a voltmeter measures terminal voltage and not the electromotive force. Hence, in order to measure the electromotive force of a battery, such a device should be prepared that during measurement, the current flowing through the battery is 0. Such a situation can be realized by constructing a potentiometer. Potentiometer is an arrangement by which continuously variable potential difference is obtained, and it can be measured also. This can be understood from the following description of the principle of potentiometer. The principle of potentiometer. A battery of EMF epsilon and an internal resistance R is connected in series with the resistance R and a conducting resistive wire having a uniform cross section. Suppose that the length of the wire AB is L and its resistance per unit length is ρ, so that the total resistance of the wire is L into ρ. If the resistance in the resistance box is R, the current length through the wire is, according to Ohm's law, I is equal to epsilon upon R plus L into ρ plus R. If the length of the wire from A to C is L, then the difference of potential between A and C will be I into L into ρ. Writing this as VL, we get VL is equal to I into L into ρ. Substituting for I from the equation, I is equal to epsilon upon R plus L into ρ plus R. VL is equal to epsilon into ρ upon R plus L into ρ plus R into L. The potential difference per unit length of the wire VL upon L is called its potential gradient. Thus, along the wire, a uniform potential gradient is established. Thus, potential drop between any 2 points along the wire is proportional to the separation of the points. The points A and C are now like two terminals of an electric cell, A being positive and C being negative. By changing the location of point C, different values for the potential difference can be obtained.